Thanks again, everyone, for joining us here today. Again, the title of today's session is Deep Dive into Lambda Layers and the Lambda Runtime API. Again, my name is Chris Munz. I am a Principal Developer Advocate here at AWS in the serverless space. I've been here at AWS a little over 6.5 years total across a number of different roles, and for the last 2 years focused solely on the serverless space. And so I spend a lot of time with our customers all over the world talking to them about what serverless is, what Lambda is, what the rest of our portfolio of products in the space is, and how you can use them to build applications that are high scale, have very low maintenance overhead, and can do all sorts of really awesome things that we find are very much game-changing about the space of serverless. So what are we going to talk about here today? Well, we're just a couple weeks past the yearly conference that we have here at AWS called AWS reInvent. And reInvent, which happened just at the end of November, much like the reInvents that we've had for the last couple of years, was a really exciting event full of a lot of awesome new features and capabilities being announced by AWS service teams. In the serverless space, Lambda had a number of announcements. And so Lambda Layers and the Runtime API are two of the key new announcements that we made back at reInvent. So again, we're primarily focusing just on Lambda here today. We're not going to touch much on any of the other services, but we're going to be talking about some pretty core capabilities. Now, I am going to start with the assumption here that you have some understanding of what Lambda is. And again, Lambda is a compute service that allows you to write your code, upload it to the service, connect it to an event source, have your code talk to whatever it might need to in terms of databases or data stores or anything like that, and be able to do what it is that the business logic that you've written in your code need to do. Pretty straightforward way to visualize that is what you see here. So again, a serverless application is typically made up of three components: an event source, which is used to actually kick off or invoke your Lambda function. Today, there's well over 30 plus services that can invoke Lambda directly, as well as your ability to use the Lambda API itself inside your own code to invoke Lambda functions. And these represent things like changes in data state, request endpoints like API endpoints, changes in resource state, so responding to, say, changes inside of your AWS infrastructure, and a number of other things. You can get messages into queues or into message bus systems. And again, there's a lot more that is involved in that than we're going to go into today. You have your Lambda function, which today could be written in a number of different languages, and that's very much key to what we're going to be talking about here. At reInvent, we did announce support for Ruby as a language that we are providing here from the Lambda team as a managed language. And then the Runtime API, which again we'll talk about here at the end or towards the middle part here of our session. And then lastly, there's the services that your code connects to. And again, this could be anything from databases to data stores to other endpoints that exist that are, say, APIs or even sockets that are open on a port and a network somewhere inside of a VPC. So do pretty much anything you'd want to inside of a Lambda function with your application code, much like you would do anywhere else. Now, when we talk about the actual code that goes into a Lambda function, there's kind of three main components of that function that you care about. There is the handler function, which is the code that are essentially the point inside of your code that we are going to first invoke and pass in an event structure and a context object, which we'll talk about here in a moment. And so typically the handler, again, you could think of as that entry point where your business logic typically starts. There's the event object, and much like the name for this sounds, this is the object that would be passed in via the event. Today, this is just a JSON structure that would contain all sorts of relevant information to the event that calls the invocation of your function. So if your function was set up to be configured to be triggered by, let's say, an S3 bucket, then the object would contain information such as the bucket and the object key. If it was for an API gateway, you would get all sorts of information about headers, path parameters, and other information about that API call, for example. And then lastly, the context object, there's a number of different things the context object can provide to you. It's kind of a mix of information about the runtime, information about your configuration of your function, and other things that you can use to interface back with the underlying Lambda service itself. And so really basic code sample here. This is in this case for a Java snippet. We've got a public function. It takes in an event object and our context. But now this is really, really basic, and very quickly what often happens is that your code starts to evolve from just a handler into something much more. And so if we were to step past is typically we're going to have, again, and this is by and large today pseudocode, so don't expect this to be entirely accurate to any one language. But we have here our handler. And now what we're going to say is inside of our handler, based on the event logic that comes in, and very quickly what will happen is that your code will start to evolve and start to grow. And so we see here, and also just to be clear, a lot of the code you're going to see here today is much more pseudocode than particular to any one language, let's say. But we have my handler. My handler, again, takes in my event and context objects. And then what we see here in the handler is that I'm going to parse that event. And based on what came into my event, I'm going to call either a subfunction A or subfunction B, let's say. And now these subfunctions, really what they represent is some sort of sub-business logic that I want my function to utilize. And it's a best practice in Lambda to break this code out into another function as opposed to it being part of the handler that your function used for invocation. More so now with layers and what we'll see here in a moment, but in general, this has been a best practice in Lambda function development. And then what typically happens again is your function continues to grow in even more complexity. So it's very common today with many of the most popular languages that you're writing applications in that you are going to use some form of dependency management to bring in either third-party external code or to even share code among, inside of your own organization. And so we see here that we have some import statements. We also then have some functions that are being called before our handler. Inside of Lambda, part of the initial bootstrap of a function is that you do have the ability to execute certain code before the handler gets executed. And so this can allow you to do things like establish database connections, pull and get down, say, things like configuration information or secrets from some sort of secret storage. There's a number of things that you could do in the pre-handler space that will help you with the performance and generally the functionality of your functions. And then we see that we now have two functions defined then in our code file here that represent this pre-handler secret getter and pre-handler DB connect. And so again, what we've done now is we've added in some dependencies, and we've established some configuration information. We've got some common helper functions that we're going to call, and then we had those common helper functions defined. And this is by and large what we've seen customers do with Lambda functions across any of the languages that we've supported. And this is kind of a really simple way of thinking about the pattern of what a Lambda function will look like. You've typically got these 3 to 4 components. You have your handler, typically some business sublogic, you've typically got dependencies and configuration information, and then there will be some sort of common helper functions that aren't necessarily business logic, but are still pertinent and valuable to what it is that you're trying to do in your Lambda function. And so now this is great if we're thinking about this from just a single Lambda function, but what happens when our overall application grows in complexity? So let's say that I have an API-based workload. Like many APIs, I have a number of different API capabilities that I want to have available to my customers or whoever is consuming my API. So we see here that I have API calls for orders, forums, search, lists, user, so on and so on and so on. There could be tons of different things that I want to do with this API. And now assume on the other side of my API that I'm going to need to get some data in and out of, say, a database. And I'm probably going to have some sort of, let's say, configuration information or secrets, potentially the credentials to that database or data store. Could be things like certificate keys that I need to use to talk to another service. Could be encryption keys, all sorts of things that I might want to talk to here. And so if we combine what might potentially have to happen here and following some of the best practices that Lambda has, what you end up with is kind of a little bit of complexity here. So we see we have our API gateway, we have all of our different API routes, we have our databases and data stores and our secrets manager and something like parameter store. And then in the middle, connecting between these are going to be our Lambda functions. And again, our Lambda functions are going to have our handler code, they're going to have the dependencies that they need, configuration calls that they need, the common helper functions, maybe those things that are pulling the data out of the secret manager and parameter store type of services, and then our business logic. And now depending on our API structure and what it is that we're doing here, there could actually be quite a lot of duplication across these. If we think about each of these API calls here, if each one of them needed to get secrets out of secret manager or parameter store, and each one of them needs to connect to a database, we're looking at here 5+ copies potentially of the same lines of code over and over again inside of our individual Lambda functions. And so this could be a lot of duplicated code. It could cause there to be potentially a lot of drift or a lot of things that might need to change over time. And again, we want to simplify as much as possible the process in writing applications. Today already, Lambda does a lot to simplify just the overall operational burden that's placed upon developers and upon consumers and people who want to build applications. But in the code writing itself, can we make this easier? And now ideally what we would have is something that looks a little bit more like this, where our functions are really streamed down to basic logic that's going to process an event and then call some sort of other business logic. And then ideally we'd like some way to standardize or share across all of these functions this other code. And now we could do this using, say, native packages and the languages that we're writing. And so we can write a whole bunch of native packages and include those. But there might be times where that doesn't necessarily cut it for us. And we might want to actually have it be a little bit more granular to the application level than all the way down to the code base level. And so essentially, this is what Lambda Layers gives you the ability to do. So with Lambda Layers, you have the ability to really easily share code. You create a layer, which we're going to do today in a little bit here. You upload it once, and then you can reference it within any function. So again, going back to our API diagram, we could have 30, 40, 50, 60, 100 different API endpoints that we're calling off of that one API and have them sharing a single layer or multiple layers shared that provide this shared code across all of those different functions that we have. And layers could be anything. Really, at the end of the day, it's a blob of data that goes into a zip file. It can be native code and language that you're writing. It could be text files. It could be machine learning training data. It could be binary data. It could be anything that you want to basically get into the execution environment of a Lambda function. But what's really great about this is there's a lot of different benefits that come with this. So a big one is being able to offer up separation of responsibilities. In many of your organizations, there are typically controls around what open source packages you can use, what versions of them you use. Security might want visibility into them. Or even in just a smaller, say, startup organization where you want to make sure that you are maintaining some sort of consistency to the packages and the versions that you're using, again, for performance, security, or feature and capability reasons. And so with this, you can just relate your code to a layer and then interface with that code that's in the layer or whatever data might be in that layer as if it was in your actual function or application directly. And we allow you to share these layers both within an account, across an account, and even publicly. And so you can take code, put it into a layer, again, share it across an organization, share it across account, and share it with general consumers out on the internet. So the way that a layer actually works here when you want to use it is you take your common components and you put them into a zip file and you upload it as a Lambda layer. And again, I'm going to show this here in motion in a little bit. Now, layers are immutable and they are versioned automatically as you upload new versions of your layer. And so we see here an example where I have one layer and then I have version 2 and then I have version 3. Now, I can allow all three of those to exist. I can delete them. I can always maintain just a single one, but these are considered immutable. And it's a very important key to how layers actually work behind the scenes. Now, when a layer is, or when a version is deleted or permissions to it are revoked, the existing functions that consume that layer still have the ability to consume it. What we actually do is when you upload a function, we basically behind the scenes merge in the layers with it. So you don't have to think about worrying if a layer has been deleted or again, permissions have been changed. But once a layer has been deleted, you can't go back and re-reference it anytime that you go to create or update a new Lambda function. Now you can have up to 5 layers inside or attached to a Lambda function. And one of those could optionally be a custom runtime, which again, we'll talk about here in a little while. So how do layers work behind the scenes? So again, when you create a layer, it gets uploaded independently as a zip file. So it counts towards the overall limit that your account has for storage within Lambda, which is a soft limit that you can put in a ticket for to get increased at any time. The code that you put or the data that you put into that zip file is going to get placed into the /opt directory in the execution environment for your Lambda function. And now an important thing to note here is that, again, we allow you to have up to 5 different layers, but these layers are effectively stacked in an order, and this is based on the order of their definition. And so what this can mean is that you can think of it much like effectively an onion file system where you have the ability to effectively overwrite files that are downstream. And so there are reasons that you might want to do this. There are reasons that you'd want to know about it just to be cautious about doing it. But it is one aspect of how layers work. So for example, here we see that an example of an idea that you can have a first layer that could be a custom runtime. A second layer could be specific libraries to that runtime. A third layer could be configuration information. And again, everything that's going to happen is all of that data that's in the zip files is going to get effectively merged down into the /opt directory in the order of definition and be available to your code and to your function that's running. Now, inside of that /opt directory, we do put things in specific places for specific runtimes. So if you're using, as you see here, Python, we're going to put it potentially into the Python folder or support it being in the Python/lib/Python 3.7/site packages directory, right? Effectively, the site directory is for Python. You see the definitions here for the other languages. And now, if you are using a custom runtime, it's just going to be in /opt/bin or /lib. And so your code will have to know how to reference that. Now, what we've done for all of the managed languages is that we've actually extended the path for the execution environment so that it automatically can find these. So you don't have to do any sort of weird importing to, say, this obscure directory that you wouldn't think of otherwise. You just import or refer to your code, and we automatically basically, it'll figure out where it has to go based on the path of the execution environment for you. So Lambda layer permissions, again, I kind of mentioned this already a little bit here. Layers can be used within an account, across account, or shared publicly with the overall developer community. Here on the AWS side, we've published already at least one layer which has NumPy and SciPy, which are two really common and important libraries for doing scientific research in Python. And this is, again, just as kind of an example of what's possible here. We are looking to expand this. We are looking for feedback on what kind of layers you'd like to see us provide to you as customers. And so, get that feedback to us. Leave it here in the Q&A and in the chat box here, and we're happy to take that. Or you can reach out to us on forums, on Twitter, and all sorts of places, and let us know where you'd like to see us offer up managed layers for you. In terms of the API, so again, here at AWS, everything we do is a API at the end of the day. With Lambda layers, there's no exceptions to this. So we updated the create function and update function configuration API to support the ability for a function to reference layers. And then layers themselves have a number of APIs, all pretty straightforward here. And you're typically not going to interface with these directly. You're going to be using the CLI or CloudFormation or SAM or the console or another SDK to interface with these. But I always find that it's viable to see the APIs for a service because it gives you a little bit more of kind of a mental model for how that service works. So real quick, let's step away from layers, talk a little bit about how you might want to think about building and managing layers. So we have here at AWS something that's called AWS SAM. AWS SAM stands for Serverless Application Model. And so SAM is a tool that you can use to manage your serverless applications. We've extended this here after reInvent to support both layers and something called nested applications, which there is another webinar this month on nested applications and the serverless application repository. Check that out. And so what SAM does, pretty straightforward here, is it allows us to create a template file. And that template file can allow us to build, manage, and deploy our serverless applications using way less code and taking way less time than pretty much any other template-based tool would take us. So see here, pretty straightforward structure. There's basically three things going on in this file. We've got some headers at the top. The most important one is this transform line. Transforms are a capability of CloudFormation that, much like the name sound, basically says, tell CloudFormation, take this template and transform it into something else. And so the roughly 20 or so lines that you see here in the SAM template would actually get transformed into about 80 or so lines of raw CloudFormation. Thankfully, you don't have to write all of that. And then there's two other kind of main aspects to this template file. All the way at the bottom, there's something called a resource that's named list table. It's of the type AWS Serverless Simple Table, and it's basically just a DynamoDB table with a basic 5 read and write units. But then in the middle here is maybe where it's a little more interesting. So we have a resource named getHTML function, It's of type AWS Serverless function. And then it has properties that represent both Lambda and an API endpoint. And so what comes out of those roughly about 9 or 10 lines of code is going to be a Lambda function, an API gateway with IAM policies tied across them, code deployed into the Lambda function. And so basically we get a running application stack with just what's here. So again, really, really simplifies the work involved in managing serverless applications. Another way to visualize this here is this is a sample that we have up at GitHub today, and from basically approximately lines 10 to 25, so just 15 lines of code, it's going to create for us 7 different AWS resources. We see here Lambda functions, an API gateway deployment and stage. We see some policies and roles. And so again, all of that comes from some really simplistic code. And if you actually spend some time to look at this code, you see that 4 of those 15 lines are for environment variables, and some of it's for some pretty basic stuff. So SAM has, again, a number of capabilities. It has 5 special resources in it today: function, API, simple table, layer version, and application. And again, application is for nested applications in SAM and Serverless App Repository. And so this is a function here. Again, you can define almost any aspect about a function. But if we look at layer version, again, relevant to what we're talking about here today, it's pretty straightforward. We define where the code is for our layer. We define compatible runtimes. We can define the license that is aligned with our layer if we were sharing it, say, internally or across teams. And then what to do in terms of retention for deletion of this. Do we keep the code available or do we delete it? And so the retention policy is pretty key. Now, SAM has a kind of a companion tool aspect to it, which is the SAM CLI. And so the SAM CLI is a tool that you can download and run on your local laptop, on workstation, up on the cloud, wherever it is that you want to run it, that allows you to do a number of different things today, actually. It's really grown in complexity itself over the last couple of months. But in terms of layers, it'll allow you to build and test layers locally. It allows you to test Lambda functions in general locally via what's considered a proxy style mock API gateway, or by creating a mock Lambda service interface locally, again, where it is that you're running the SAM CLI. So it's a really powerful tool. It can also help you with packaging and deploying. It can help you validate your SAM templates. It can tail logs. It can help you build the native dependencies. And so a bunch of good things that you could do here with this. And so let's take a little bit of a look here into using SAM and working with SAM to build a serverless application, and then to modify that and turn it into a layer. So what I've done here is swap over to a Cloud9 instance that I have up and running. Cloud9 is a managed IDE that we have here at AWS, and it's a great place to do your development. So I do all of my development here in the IDE. And behind the scenes, it is just a straightforward EC2 instance. And so I have access to all of the kind of underlying capabilities of a running Linux instance here. Now, I currently have the SAM CLI installed and updated, so that's all good to go. The AWS CLI is updated and installed. Kind of everything I need to do or need to use to build my application is available right here. Let me actually just make this a little bigger here. So what I'm going to demo here is a really simple, basic application. I've got some data right now in AWS Systems Manager Parameter Store. And the way the Parameter Store works is it allows me to create basically parameters that can exist inside of a certain hierarchy, and then I can pull down those parameter information as I want to inside of my application. And so this is really useful for things like configuration information, feature flags, pointing to, say, things like database endpoints or other service endpoints. You can optionally encrypt the data inside of your parameters using KMS. And also it plugs into Secrets Manager, which is kind of another companion product that helps you with things like key rotation and policies around that. So pretty cool product, has a lot of capabilities in it. All I'm doing with it is something pretty cheesy. I have a parameter that is in the path name of /messages, and it's called, the name of this specific parameter is IAM. And so, hi, my name is Chris is the value in this. And for the other one here, where it is also in this /messages path, I have something called webinar, and it says hello world. And we'll go ahead and we'll add one more parameter here. And so again, we'll call this /messages, and we'll say something like demo. And we'll say, hope you are enjoying the demo. Great. So nothing terribly exciting about this one. And that's been saved, and so we've got demo here. Now what I also have is I have a code directory, and I'm just going to go real quickly here and clone this directory. And so I have this directory stored up in code commit. And you'll see here it's really pretty basic. It's got a git ignore, a single Python file, a requirements.txt, and a template.yaml. So we go back here to my Cloud9 environment. Let me go ahead and clone this. Should just take a moment or two. Cool. So now you can see here on the left is that it's updated my directory tree with everything that I have in here. Again, I've got my app, I've got my requirements, and my template.yaml. Now, real quick here, the template.yaml again is my SAM template. This is really, really straightforward. I have a single resource called param-fetcher. It has a handler. It has some policies. And again, I've pre-created these for today's demo. So it's got IAM policies related to it. And it has a really basic event, which is just on the root of my API, do a get call, and it's going to return something to me. Now, there are some requirements I need for this. So because I'm talking to parameter store, I need an AWS SDK to do that. So I'm going to use Boto. I'm also going to potentially want to trace the calls for that. So I'm going to include AWS X-Ray, which allows me to do profiling, troubleshooting of service calls and of flows in my application. And then I need the Python tools setup tools. And this is actually more for how SAM CLI does some testing than anything else, but I have it included in here. Now, one cool new capability of SAM is that I can just come in here and type in SAM build. And what SAM build is going to do, let me actually go into the right directory. What SAM build is going to do is it's going to look for some sort of requirements or packages.txt or packages.json file. But basically, across the languages that we support natively, it's looking for dependency files that will have various dependencies that we want to have installed. It then goes and installs them for you. So the requirements.txt again that I had here has just these 3 packages. And so what's happened is I've run SAM build, and it's gone here and created another directory structure for me here, which has the results of the effectively pip install of my Python application. And so as those of you who are familiar with languages like Node.js and Python and Ruby and a number of others, I only included 3 other packages in my application. Those 3 things, however, included several others. It's almost about 3 dozen other packages that were included here. Now, in a perfect world, I would be pegging these things to certain versions, keeping on top of that. For today's example, I'm not following that best practice, but you absolutely should be doing that at the end of the day. Now, if I come here into the build directory, or I'm sorry, into the .aws SAM build directory, again, I have my full application. I can ask SAM, go down a little bit here. You can say SAM validates -g template file. It tells me that my template file is good. And then I could test this locally. And so I can just very easily go and say SAM local, start API-t template.yaml, hit enter. And now what this is going to do behind the scenes is it's going to go and download a specific Docker image that we have built that is open source to the community. It's actually from another project called LambCI. And it's going to pull that down, take my code, and throw my code in it. And then what it basically says is that I can come here and curl this one, curl the local interface, and I should get back a result. Okay. So we see here is a JSON structure returned to me. This JSON structure is all of the messages that I have in parameter store. And so we can confirm that my code is talking to parameter store. It is pulling down the data and sending it back to me, and I can access this via an API call. Cool. So let me actually now take this one step further and deploy this function. So go back into my, my directory here. I am here in that directory. Again, it has taken my code and put it into a directory called param fetcher, and then I have my SAM template file. I'm going to cheat a little bit here, as is the best way to do this. And I have already run these commands on this host. So the first one I'm running is SAM package. This is going to package up this application, all of its dependencies, and send it up to S3. The next thing I'm going to do is run SAM deploy, referencing my SAM template, giving it a stack name, and then passing in the capabilities command which CloudFormation needs. And this will take just a moment or two here to run behind the scenes. So this is, again, behind the scenes now, using CloudFormation. It's taking my SAM template, it is doing the transform on it, and then it is going through the flow of configuring the services as I have it shown here in my template file. Great. Okay, so this is finished. Now, I had a stack that I had already pre-created called get messages. And so it just makes it easier for me to go now and find my application. And so I am now in the Lambda dashboard in the AWS console. I am going to go down to functions in this case. And I see here that I have my get messages dash param fetcher function. This is the function created inside of the stack. I can come inside of here and see a whole bunch of information. So right now I have the Lambda function highlighted. If I come down below here, it tells me that the deployment package is too large for the in-console text editor, or the inline editing. This is very important, and we'll come back to this here in a little bit. I then run test. And in this case, I got the exact same output as I did running locally. So again, my Lambda function live running can talk to the parameter store and get out my information. Okay. Now, this is all good, pretty straightforward. One thing that's kind of a drag is that inside of this directory, I have all of these packages. And anytime that I want to update my code, I have to run the build command, go into that build directory, go and update it, and push it back out again. Every time I do that, my entire application is going to take up all of the storage required for me to store all of these dependencies. Furthermore, if I wanted to expand upon this application, it would require me to potentially duplicate this across a number of different Lambda functions. And so a lot of duplication, potentially a lot of waste here. And really, I just want BOTO, right? And so this is, again, where layers can come in and help. What I really want to do is take all of these libraries that I have, all these other dependencies, put them into a layer and just reference that layer. Well, this is really easy to do. So first thing I'm going to do here is I'm actually going to just go and delete this whole build directory that I have. So I'm going to delete this AWS SAM directory. I'm going to actually delete my requirements.txt because I'm going to assume that I do not need any requirements in here. And so I'm back to basically just the basics of my app and my template. Now I want to actually go and, let's say, create this layer and make it available. So I've already, again, gone ahead here and cheated just a small bit. I have another code repository that I'm going to show you. So let me go ahead and get a clone on this. This is a repository called Lambda Layer, Boto, and X-Ray. And let's take a look what's in here. It's pretty straightforward. I have a README that has some instructions in it. I'll go to that in a second here. I have my requirements.txt, which has the same requirements that were in my application. And then I have a template file for SAM. And now in this template file, I have a single resource. And the single resource that I have is that of a serverless layer version. And so it has really basic description. It says it's going to find this code here in the directory path. This is going to be for Python 2.7, which is what I am pulling dependencies for. I have my retention policy, and I have my license info. So pretty straightforward. Let me go here to my README file and just do the easy thing, which is copy some of the commands out of this. And so if I come back down here to my terminal window and I cd into this directory, I can go ahead and just run pip install. And again, I'll take a moment or two to pull in all of the packages that I need into this directory. And now what you'll see here is that I have created this subdirectory in here called Python. And again, this is because this is the structure that layers are looking for as part of how the API works behind the scenes. And again, depending on your language, you will need a certain directory structure. And then in here, I have all of those dependencies that I care about. That's good. Go back to my README. The next thing I'm going to do here is just go ahead and package this up. So again, I am using SAM to define my layer, and so it's pretty straightforward. Oh, I forgot to actually go and here. Apologies. So what I missed was that I forgot to reference my S3 bucket. So now I have referenced my S3 bucket. And now I could actually go and deploy this. And so come back here. And I'm just going to use SAM deploy. And again, I'm cheating a little bit in that I do have an existing layer of this exact same stack name. And so it's going to create this. Now, to some degree, I'm being maybe a little extra in using SAM to manage this. I don't have to. At the end of the day, it's going to put a zip file in S3 and create a layer for me. But what's great is that because I am creating this with SAM, I can now track this as a CloudFormation resource. And so tracking it as a CloudFormation resource gives me a number of capabilities in there. I can set things like update policies, notifications for changes. There's a lot of things that I could do because I'm doing this via SAM and effectively behind the scenes via CloudFormation. And so I recommend that you think about doing it this way, even though it is an extra step or two to get it out there. So we go back into the Lambda console and go over to layers. And so I will see here that I see my one layer here called Lambda Layer Boto X-Ray. If I go into this, I see that I have 3 versions deployed. So I just deployed the 3rd version just now. The create date was 33 seconds ago. And I can see the ARN or the Amazon resource name or identifier for this layer right here. So we go ahead and copy this. We've got this nifty little button here in the console that allows you to copy this ARN. And I'm going to go back to my code. And what I want to do is add a reference to this layer. And so pretty straightforward. I just type in layers and sub, and then the and sub being a command in CloudFormation here. Cool. So this should be all that I need here to go and include my layer inside of my function. As you see here, I'm referencing it with the exact ARN that was inside of my layers dashboard. So we come back here and do SAM package. Great. And then I'm going to, again, go and deploy the get messages application. And it's take just a moment or two for it to take the re-uploaded code and go and, as well as the layer itself, merge them together and make the change to the application configuration for them all to be set up to go here. Just another moment or so. Cool. So the stack is successfully updated. I'm going to go back to my console, go and find this function. And again, all I did was strip out the dependencies, reference a layer, and so that's all that has changed. If I come back in here to the console, I see that I have a layer referenced. I can go and click on the layer, and I see information about the layer. But if I come back up to Lambda function itself, and I scroll down here, what I now see is I can actually go and look at the code for this function. Remember, previously I couldn't do that because the deployed artifact was too large. But now that I have stripped out all of that, I get the ability to now actually go and edit this inside the console. Now, because I am using a code repository behind the scenes, I typically wouldn't want to do that. But I do have the ability to dig in and troubleshoot and be able to do that, and see here my reference to my layers. And now the most important aspect, run a test and see what happens. And I ran a test and it was successful, and there's my output. So again, what did we do here? Well, we took a function that was in the pre-layers sense in terms of the way it was defined, where my dependencies were inside of the same artifact as my code. My SAM template was pretty straightforward and referred to that. I then took those dependencies and broke them out into a layer. And again, that layer contained just those dependencies with the certain path requirements and stuff for Python. I deployed up my layer. I updated my application SAM file to reference that layer, and now they're all working and everything is good. I could go so far as to, well, again, you can see here in the left what represents my actual code artifact and confirm that there are none of the dependencies inside of just this code artifact. Cool. So that's Lambda Layers, really quick run through of that. And again, great way to share code across an organization or across many organizations or publicly. And again, a great way to streamline the amount of code that you're writing inside of your own functions. Let's continue to talk a little bit here more about Lambda. And so here at Lambda, and the Lambda team, I should say, we want to make it really easy for developers to get started without needing to worry about installing software on servers or in containers. That's something that's been very key to us, something that's been kind of one of our North Star things that we've cared about since we first launched the service. And one of the key ways that we've done that is via managing the language runtimes for our customers. It helps make it a lot easier if you don't have to think about installing software to actually run then your own application and software. And so today, if we look at where we are right now here in January of 2019, there's a number of different languages that we support and then versions of those languages. And we continue to update these and progress over time, depending on where what's being released, what is considered long-term supported, and where customers are looking for us to provide managed runtimes for them. So again, you see here a number of these. These do represent probably the majority of what are the most popular languages in the industry today. That said, it's a really long tail of languages out there. And so just two different kind of third-party ways of looking at this. There's the Stack Overflow developer survey from last year, which showed basically the top 25 languages that people were interested in from a development perspective. Now, some of these are things like SQL and CSS and HTML, which don't really fit into the Lambda concept. But still, we see other languages in here that Lambda doesn't have native support for today. Swift, Objective-C, Kotlin, a number of others. GitHub similarly has what they call their state of the Octoverse, reports on the trends that they see for GitHub repositories that are public, I believe. And so they published a list of top 10 languages as well as top 10 growing languages. And these include things like Rust and Groovy and again, Kotlin and a number of other things. And so we hear and have heard since the launch of Lambda of all the languages that you want to see go into the platform. And what we realized is that the best thing that we could do is enable it so that you could run these. And again, you care about these languages. We care about making you happy and giving you a platform that you can build stuff inside of. And so with that in mind, we also announced back at reInvent the ability for Lambda custom runtimes via something called the Runtime API. So in this case, you could bring any language that could run in a Linux-compatible environment. Again, we do run Linux behind the scenes, the execution environments for Lambda. We actually are dogfooding this ourselves. So the new Ruby runtime that we announced also at reInvent is actually powered by the Runtime API. So this is going to be kind of a standard for us going forward. You'll probably see more of our languages being supported in this. But again, it's a standard, it's performant, it's secure, it's everything that you would expect it to be from a product like Lambda. And custom runtimes can be distributed as layers. So I mentioned this a little bit before when I was talking about layers, but this is one of the cool aspects about how these two product capabilities do work together. So how does a custom runtime work? So behind the scenes, when you go to create a function, you have to specify that the runtime is of type provided. Beyond that, we have no visibility into what the runtime is that you are using, just that it is something custom that you have provided. Inside of your runtime or inside of the layer, you need to have an executable file called the Bootstrap. And now the Bootstrap is essentially what runs and owns the communication between the Lambda execution environment and your application code. And then again, your application code could be anything that you want it to be that, again, works within the constraints of being able to run inside of the Lambda Linux-based execution environment. Now, what the Bootstrap does, again, here is it acts as effectively a connector, again, between what is actually the runtime API behind the scenes and your function code. And what that means is that the Bootstrap has to be able to pass things like responses and handle error handling, handle the context creation, and then, of course, execute your code and invoke your handler. It will also have access to certain information, such as the interface endpoint and the function handler that's been configured by you, because the runtime does not need to know about your function code, actually, via environment variables. And so again, sorry, just to clarify that a little bit better here, the runtime is not necessarily going to be custom and unique per Lambda function handler, but it does need to know what the Lambda function handler is that it's invoking inside of your code. And then again, talking about APIs, so there are a couple of different APIs that are behind the scenes of the Runtime API that are things that the Bootstrap is going to be looking to communicate with. So you see those listed here. There is an initialization error API for, again, things like pre-handler and bootstrapping that you would potentially need to report on. There is the getting of the next invocation for that function. You see here then a response or potentially error based on that invocation ID that is passed in. And so down below here, you see kind of a sample of what the HTTP endpoint looks like for getting that information in and out. And so the overall steps that the Runtime API has to take is get an event, has to propagate a tracing ID, has to create the context object, it invokes the handler, it handles a response and or errors, and then it will clean up any aspects about the ending of the function that is necessary. In terms of environment variables, again, there are a couple that come in. There is the hostname report underneath the Runtime API. There is the handler, so again, where the handler in your code is going to be. And then there is the task groups, the directory that contains the function code. And this can be anywhere inside of your artifact and or a layer. So again, just to be clear, anything that can run inside of the Lambda execution environment could be executed by the Bootstrap. So you can actually get really creative about this. I've seen all sorts of different languages and stuff that I wouldn't have expected. You only have to know how the runtime itself API works, though. If you want to build and manage your own runtimes, the majority of Lambda developers are not going to use the Runtime API. And that's actually what we want. We do not want everyone to think that this is the default that they should use. You should continue to look towards the managed provided languages that we have in the platform. We will continue to maintain and grow and update those over time, again, based on your feedback and what it is that you are looking for. And so, continue to provide that feedback to us. But for those of you that are looking for some of those long tail languages or to use newer versions of languages that aren't supported, this is one way to do that. So at reInvent, we announced a number of new open source runtimes that were provided both by AWS and by our partner ecosystem, and it's continued to grow since then. So we announced a C++ and Rust runtime, which you can go and use today. We had a number of awesome partner released languages as well. So Erlang and Elixir from Alert Logic, COBOL from Bluidge, PHP from Stackery. NodeSource brought their enterprise-grade Node.js runtime to the platform as well. And actually, you could find down here in the GitHub repository referenced below a whole bunch of new and continually updated runtimes that have come out from the community. And so we're really excited to see that list there. Now, I want to really quickly here go and demonstrate, just really briefly poke at what these layers actually look like. And I'm going to use the example here of Stackery's PHP layer, which I find is one of the cleanest examples of a custom runtime that we can find. And so again here, let me cut back over to my console. So we're going to come over here to GitHub where Stackery has their custom runtime published. And we can see here it's really straightforward. There's just a handful of files. Most of these shell scripts are their tooling shell scripts for doing things like publishing updates, a list of regions, unpublishing, uploading, creating buckets, stuff like that. About 50% of what's in here is just helper content. What they do have that's interesting is the Bootstrap, which I'll talk about here in a second, as well as a build.shell file. And so for them, the build.shell file actually comes and does install, in this case, PHP locally in the environment that you're doing a build inside. It moves some directories around for you, and then at the end of it, zips up and creates the layer for the runtime. If we come back here to the Bootstrap file and take a look at what's going on in here, this is itself a PHP file. It references where inside of the layer PHP would live after the layer was configured. And then it's pretty straightforward. It starts a web server by looking for where the port and handler should be for the process running inside of the environment. It's got a number of helper functions like a failure helper. And as we go down through here, you'll see a couple of others. But basically, again, what it does is just make it easy to run PHP code. And so there's a bunch of again, functions and capabilities in here that will help execute your code. Now, if you go back up to the start web server, again, we see here where it's basically just going to be looking to execute your code and handle your handler and pass in the code for you. So it's pretty straightforward. It's pretty easy to get started with. And they have a really nice walkthrough to get you there. Just as an example of this up and running, I have a Lambda function that I walked through their walkthrough. It took about 2 minutes to get set up and running. And this is living on the other side of an API gateway. You see here that it is of the type PHP test. It is, or sorry, the function name is PHP test-PHP server. The layer represents a public layer that was published by Stackery. And then if I come down here to my gateway configuration and go and open this up, I will get the output from this. And so I made my function just spit out PHP info. For those of you who are familiar with PHP, this is a way to get information about your underlying operating system and host that is running PHP for you. I have to admit that seeing this being generated by a Lambda function was pretty cool the first time. It was pretty interesting. I very early into my career used to write PHP almost 19 years ago, actually. And so it's pretty exciting to see PHP being spit out of a Lambda function like this. And again, you can bring any language you want to the runtime. So with that, we've talked about a lot of different things here today. About just two small components, really. We've talked about layers and the Runtime API, two new really awesome components or capabilities for AWS Lambda, which is kind of core and center to the serverless platform for us here at AWS. You could read a lot more about everything that I've talked about here today by going to aws.amazon.com/serverless and clicking through the various different products in the documentation. You can also get to things like the SAM landing page, to other resources for webinars, blog posts, and other bits of content that you can learn more about this as well. There's just a wealth of information that you could find about these topics linked off of this page. Again, my name is Chris Munns. You can find me at munns@amazon.com or hit me up at Chris Munns on Twitter. Happy to try to answer questions. I know we've been answering questions throughout the webinar here today. Keep those coming. We're going to try to get a couple more of those answered before we have to end today. Again, in general, I want to thank you all for coming and listening. Hope to see you in some of these tech talks again here soon. And have a great rest of your day. Thank you.